So in this video we are going to discuss about deadlock and conditions for deadlock, right? So what is deadlock, right? Suppose I have two or more processes, right, and this is happening, these are happening for some event, but that event does not happen, right? For some event, but that event is not actually happening. So those processes are in which deadlock state, right? For example, I go to bank. In bank, I say I want to deposit amount and please open my account. But bank says first open your account, then deposit. So this is a deadlock condition, right? Or suppose there are two cars, this going in this direction and this going in this direction, opposite direction. So these two cars are in deadlock situation, right? Now I will process P1, suppose, and this has semaphore S1 and this waits for S2. Suppose I have processed P2 which has semaphore S2 and waits for S1. So this is a deadlock condition, right? Now suppose I have what? I have P1, right? And process P1, resource R1, right? R1 is allocated to process P1. P1 is requesting for resource R2. R2 has allocated process P2 and P2 is requesting for R1, right? Now what happened? There are four necessary conditions for no deadlock, right? So this is not actually a deadlock. Why? Because it is kind of circular thing, right? When things get like this, right? When a circular condition happens, this might seem a deadlock, but actually it is not, right? So now we will be discussing about four necessary conditions for deadlock. So let me erase this. First is what? First is mutual. Sorry, let me erase this again. Yes, first is mutual exclusion. Mutual exclusion. Second is what? Second is, sorry, let me erase this again. Second is what? Second is no preemption. No preemption. Third is hold and wait. And fourth is circular wait. Right. Now, whatever resource you use must use in mutual exclusion. Means more than one device cannot go for same process, right? That is my mutual exclusion, right? Now preemption means all resource must be used by devices in mutual exclusion manner one by one. And suppose I have what? I have, suppose my printer is having process P1, it made it print, and same time P2 it is making it print, but it cannot preempt P1, right? It cannot wait P1. For example, P1 hold R1 and wait for R2, right? So this should be happen. Suppose I have P1, it cannot hold P1 and then go for P2 and print, right? So this is mutual exclusion and no preemption. Hold and wait means P1 hold R1, resource 1 and wait for resource 2, right? So there are how many number of resource, it should hold and wait for another resource, right? And whenever a loop is creating, right? So this is not, the loop means circular wait. So whenever this kind of situation arises, it means there is no deadlock condition, right? So this is all for today.